What we're looking at here is the Maclaurin series. It's a general Maclaurin series for f of x. We want to figure out what is the Maclaurin series for sine x. We want to do it just like how we had figured out this general Maclaurin series in a previous video. I recommend you watch it. Alright? Now, I looked online for the Maclaurin series for sine x. Let's see what I found. I found this. It's x minus x cubed over 3 factorial plus x to the 5 over 5 factorial minus, and so on and so forth. So let's write it down. So the sine of x, and remember the angle x is in radians, alright? It is equal to, we have x minus x cubed over 3 factorial, but this x, is really x to the 1 over 1 factorial, alright, minus x cubed over 3 factorial plus x to the 5 over 5 factorial, just like this. What's the next term you think would come? You notice x is raised to odd powers divided by the factorial of the odd numbers, and we switch between plus and minus. So next will be minus x to the 7 over 7 factorial plus x to the 9 over 9 factorial minus x to the 11 over 11 factorial plus x to the 13 over 13 factorial minus x to the 15 over 15 factorial, and so on and so forth. Will be plus. Right? You get the idea? Alright? Now, how can we get this thing? Right? What would it be if we figure it out from the general power series? Let's see. The sine of x, it is a power series, and the power series is generally in the form number a x to the 0 plus b x to the power of 1 plus c x to the power of 2 plus d x to the power of 3 plus e x to the power of 4 plus, and so on and so forth. A, B, C, D, E, and so on, those are constants. Alright? Now, here we need to know what A is, what B is, what C is, and so on. How do we figure out A? Well, let's see something here. When we say x to the 0, whatever x is, x to the 0, the power of 0, is equal to 1. So we could just write A, and then of course x to the 1 is just x. So here, f of 0. Suppose we make x equal 0. We would have sine 0 as root theta. Sine of 0 is equal to a plus b times 0 plus c times 0 squared plus d times 0 cubed plus, and so on and so forth. But all of these would be 0 because d 0 multiplied by them would be 0. Now, sine 0 is a. What is the sine of 0? Now, you should remember, without using the calculator, that the sine of 0 is equal to 0. Alright? So we know that a is equal to 0. Good. Now, we know a is 0. Let me write it up here. We know that a is equal to 0. Alright, good. Now, how do we find b? Now, here, notice, if we should differentiate all of this, this would be 0 because it's a constant. And when you differentiate a constant, you get 0. X to the power of 1. When you have a number times x and you differentiate that with respect to x, you get the number itself. Because 1 would be times this and 1 minus 1. Well, you should remember the power rule when you're doing differentiation, right? So, let's find the first derivative of sine x. Right? So, what we have is that the derivative with respect to x of sine x is equal to first derivative. This is 0, so it's 0 plus 1 times b is 1, x to the 1 minus 1 is 0, so it's b plus 2 cx, because remember 2 times c, and you multiply by the power is 2c x to the 2 minus 1 is 1 x, 2c x to the 1. You see that? Plus, then 3 dx to the 2 plus 4e x to the 3 plus, and so on and so forth. All right? Now, what happens if we make x equal 0? So, d by dx of the sine of 0 is going to be 0 plus b plus 2 times c times 0 plus 3 times d times 0 squared plus 4e times 0 cubed, and so on. Whatever is multiplied by 0 goes to 0. Oh, when you differentiate sine, I didn't differentiate it yet. When you differentiate sine x, what do you get? You get cosine x. So the derivative with respect to x of sine x is equal to cosine x is equal to all of this. So the cosine of 0 is what? 1. Right? You should remember. You shouldn't have to use a calculator. That's another thing you should remember. You should remember the sine of 0 is 0, the cosine of 0 is 1. So, here, you can see that b will be equal to 1 based on that argument. So, b equals 1. Alright? So, we got that. Now, that was the first derivative. And we found that b is equal to 1. Second derivative, d squared by dx squared, d squared sine x by dx squared. Now you already found the first derivative of sine x. So it's going to be d by dx of, you differentiate it once, you get cosine. So you need to differentiate cosine x now. Sine cos. You remember what the cosine of, what the derivative of cosine is? It's negative sine. So it's negative sine x. Alright? You differentiate sine. Let's write it over here. You're differentiating sine x. You get cosine x. You differentiate cosine x. You get negative sine x. What do you get when you differentiate negative sine x? Remember, when you differentiate positive sine x, you get positive cos x. So when you differentiate negative sine x, you get negative cos x. When you differentiate negative cos x, you get, remember, when you get When you differentiate positive cos, you get negative sine. So when you differentiate negative sine, you will get positive. When you differentiate negative cos, you get positive sine x. And then the process repeats itself. You see that? So anyway, negative sine x. So that's the second derivative. Right? So what we had, let's not leave it out. Let's put it further down here. We have d by dx of sine x is equal to cosine x. Right? So d squared by dx of sine x squared of sine x would be d by dx of cos, which is negative sine. Alright? Now, d by dx of sine x is cos x. So this cos x is the same thing as this. Alright? So, it is b plus 2cx plus 3d x squared plus 4e x cubed, and so on and so forth. I expect that the next one would be 5f x to the fourth, alright, plus, and so on. Now, here, we have the derivative of cos, which is negative sine. So negative sine x is equal to, now remember, the derivative of cos x means you're going to differentiate this. When you differentiate b, you get 0. Plus, when you differentiate 2cx, you get 2c. See that? Plus, when you differentiate 2dx squared, you get 2 times 3. We won't multiply the numbers. Dx, remember there's a power rule. Plus, when you differentiate 4ex cubed, you get 3 times 4 e x to the x squared. Plus, when you differentiate, well, we didn't have this before. I just put this in. So, we will probably won't work up to that stage. Alright. So, this is sine of negative sine x equals this. Now, we want to make x equal 0. So negative sine of 0 is equal to 0 plus 2c plus 2 times 3 times 0 plus 3 times 4, d times 0 plus 3 by 4 e 0 squared plus and so on. Plus 0 squared is 0 and 0 times this is 0. 0 times d by 2 by 3 is 0. So here, 2c is what you have here. What is the sine of 0? It is 0. So 0 is equal to 2c. So c would be 0. See that? So let's write it down here. So c is equal to 0. Next we want to figure out what d is. Alright. Now, let's rewrite this. Negative sine x equals, this is 2c plus 2 times 3 dx plus 3 by 4 e to the x, e x to the 2 plus and so on and so forth. Now, we must differentiate this and equate to 0 in order to find out what d is. And you see how it works. D by dx of negative sine x is equal to. And remember, you know, this would be the third derivative. It's just that we did the first this and the second derivative. When you're going from the second to the third derivative, I just differentiate once. That's why I put d by dx here, because the other differentiations were done already. Right? We differentiated sine x, we get cos x. Right? Then differentiated cos x, we get minus sine x. That's 2 so far. Then we need to differentiate minus sine x. This will be the third derivative. But anyway, we differentiate minus sine x. What do we get? What do you get when you differentiate negative sine? It's going to be negative cos. So down here is going to be negative cos x equal. But let's deal with this part out here first. When you differentiate this, 2c is a constant, you know, so when you differentiate 2c, you get 0. Plus, when you differentiate 2 by 3 dx, you get 2 times 3 times d. Plus, you differentiate 3 by 4 e to the x squared. It's going to be 2 times 3 times 4 e, I said e to the x squared. Ex to the power of 2. But you're going to reduce the power by 1. So it's e x plus, and so on and so forth. Now, here, if you have the derivative of negative sine x, you get negative cos x. Let's leave out this 0. We have 2 times 3d plus 2 times 3 times 4 ex plus. Now, what is the cosine of 0? Let x equal 0. What would that? Negative cos 0 would be equal to 2 times 3d plus 2 by 3 by 4e times 0. So it's 2 times 3 times 4 times e times 0. This would be 0. All of these things to the right would go because there would be all zeros. So now, here, what cosine of 0 is 1. So this is negative 1 equal 2 times 3d. Now when you divide by 2 times 3, by 2 times 3, d would be negative 1 over 2 times 3. So d equal negative 1 over 2 times 3. Right? Now you could continue it. If you put in, well, with an e. Let's continue so that we get the e. We find out what e is. Now, what we had was cosine, negative cosine of x. You differentiate and find the derivative of negative cos x with respect to x is equal to. When you differentiate that, all of this is a constant, you know, 2 by 3 by a constant is a constant. So it's 0 plus, this will be 2 times 3 times 4 e. When you differentiate a number by x, you get the number. And you remember the power rule and how it works, alright? Plus, these would, whatever is to the right, would have zeros in them, would have x in them. X is in them. And when you find the derivative of negative cos, you're going to get positive sine x equal 2 times 3 times 4 times e plus whatever happens out here. But these would be 0, so you wouldn't need to worry about them. Here, when you make x equals 0, sine of 0 is 0. So what you have is 2 times 3 times 4 e. But since this is 0, e would be 0. So E would be equal to 0. Alright? Alright, so we have these so far. Let's see what would happen when we put it back in the general. Put them back in the general power series for sine x. Sine x is, let's repeat this, or we could copy it. Let me just copy this thing. Copy and combine them. And then put it over here. Okay. Nice. So, what we have here is the sine of x equal a, which is 0. Right? Plus b, which is 1. Plus c, which is 0, 0x squared. D is negative, so plus negative means minus 1 over 2 times 3 x cubed plus e is 0. Alright. Now, it would be interesting to see what the other term would be involving f. If we had an f x to the 4, when we differentiate and have our 5 f x to the 4, this would be a 4 times 5 f x to the 3. Then when we differentiate down here, we would have plus 4 times 5 fx cubed. Then when you differentiate it, this part would turn out to be 3 times 4 times 5 fx squared. Then you come down here, this would be 3 times 4 times 5 fx squared. This will go to 0 here, but when you differentiate 3 by 4 by 5 fx squared, right? Differentiate once more. When you have negative cos, is this. You had differentiated 2 by 3 by d to get 0. You differentiate 2 by 3 by 4 ex to get 2 by 3 by 4e. Let's differentiate 3 by 4 by 5 fx squared. What you would get is 2 times 3 times 4 times 5 fx. Alright, good. Then what we would have here is this plus 2 times 3 times 4 times 5 fx. When we make x 0, this would go to 0. So it's plus 0. But then, differentiate once more. Right? When you find the derivative with respect to x of sine x is going to be equal to, when you differentiate this up here, this is what we're differentiating, right? When you differentiate it, this would be a constant, so it will go to 0. But this part now, what would happen to it? You'd have 2 times 3 times 4 times 5 f. And then f would be what? Well, oh, when you differentiate sine, you get cos. It should have been cos. Right. So f, first of all, before we do that, we want to make x 0. Cosine of 0 is 1. 1 is equal to 2 by 3 times 4 times 5 f. Then we divide by 2 by 3 by 4 by 5 to get f. So f would be equal to 1 over 2 times 3 times 4 times 5. Alright, so let's add this to it now. F is 1 over 2 by 3 by 4 by 5. So f is equal to 1 over 2 by 3 by 4 by 5. Okay, good. So I'd left off the f originally, but I see that you need it to complete this thing. So we would have f after the e x to the fourth, it will be f x to the fifth plus and so on and so forth. So this would be 1 over 2 by 3 by 4 by 5 x to the fifth. Alright, so sine x is therefore equal to what now? 1 minus, now you notice the 2 by 3, it can be written as 1 times 2 by 3, which is the same as 3 factorial. So this would be x cubed over 3 factorial. Then plus this 2 by 3 by 4 by 5 can be written as 1 by 2 by 3 by 4 by 5. And this would be 5 factorial. So it's something over 5 factorial. It's x to the 5 minus, and you go on like that. So sine x, let's compare it with what we had. 1 minus x cubed over 3 factorial, 1 minus x cubed over 3 factorial, plus x to the 5 over 5 factorial, plus x to the 5 over 5 factorial, minus, and so on and so forth, right? So that is the Maclaurin series for sine x, all right? Now, it would be good practice for you to do a little homework here. Put sine x there and make x 0, you get 0. You get 0 here. Plus. Differentiate sine x, you get cosine x. This would be cosine of 0, which is 1. This x. Plus. When you differentiate, well, cosine of 0. Alright? When you differentiate cosine, you get negative sign. Here you will get a negative sign, and that will be the second derivative right here. When you equate to 0, sine of 0 is 0. So x squared over 2 factorial times 0, this would go. So this is gone, this is gone. But when you reach here, you take negative sign, differentiate it, you get negative cos. And this is a minus. Negative cos 0 is negative 1. X cubed over 3 factorial. Right? It's a nice homework for you to do. Just substitute the values here and see what you get. You should get the same thing as what we obtained here for the Maclaurin series of sine x.